Okie doke, we're going to get started with section 1.1, the introduction to the practice of statistics. So first let's start by defining statistics and statistical thinking. So statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So you're drawing conclusions, you're answering questions with those conclusions usually, and you have some measure of confidence. And then data, that's going to be facts or propositions that are used to draw conclusions. So a couple places that you can get information, if you were just looking for some raw data, would be the New England Journal of Medicine. But you do have to be careful, even with something as nice as New England Journal of Medicine, that sometimes they also have a little bit of bad research in there too. All right, so let's talk about the process of statistics. So the entire group of individuals to be studied is the population. So the population is everybody that you're studying. An individual is a person or an object that's a member of the population being studied. And a sample is the subset of the population being studied. So the population is everybody within a category. So this is where you would define it. So if we wanted to study all females at Gwinnett Tech, then the population would be every single female at Gwinnett Tech. An individual would be one of those females at Gwinnett Tech, and a sample would be the people that we chose to get information from. So a parameter is a numerical summary of a population. So it's of everybody. So it's a summary of everybody. So this might be like a mean or an average, things like that. A statistic is a numerical summary of a sample, and descriptive statistics consist of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs. So statistic is about a sample, and parameter is about a population. So the statistics about the sample that you took or that the researcher took, and the parameter is a number describing the population. So let's look at a couple of examples really quickly. So we're going to look at the population and the sample. So the Gallup organization contacts 1,028 teenagers who are 13 to 18 years of age and live in the United States and asks whether or not they have been prescribed medication for any mental disorders such as depression or anxiety. Well, the sample is going to be the people that were contacted. So the sample is going to be those 1,028 teenagers that are between 13 and 17. And the population is going to be all teenagers between 13 and 17 in the U.S. So the sample, the 1,028, any information gained from that sample we're gaining so that we can make some conclusion about the population. Because really, we're not concerned about those 1,028 teenagers. We want to be able to draw a conclusion and apply it to all of the 13 to 17-year-olds in the United States. Okay, so for B, a farmer wanted to learn about the weight of his soybean crop, so he randomly sampled 100 plants and weighed the soybeans on each plant. So the sample, he randomly sampled 100 plants. So his sample is going to be those 100 plants. And the population is the thing that he was wanting to study to begin with. So he wanted to learn about the weight of his soybean crop. So it's going to be all the plants in his soybean crop. So again, what he was wanting to study, or what he was wanting to be able to draw conclusions about, was his soybean crop. So that's the population. And then the actual plants he used to do that are going to be the sample. All right, let's look at a couple things here. And we're going to determine if the underlined value is a parameter or a statistic. And remember, parameter goes with population. So that's everybody. And the statistic is going to go with the sample. So that's just the people that were sampled to get that number. So telephone interviews of 1,502 adults 18 years of age or older, conducted nationwide February 1st through 13th in 2007, found that only 69% could identify the current vice president. This 69% is talking about this 1,502 adults. So because this is only about this specific set of adults, this is going to be a statistic. For B, batting averages, Ty Cobb is one of Major League Baseball's greatest hitters of all time with a career batting average of 0.366 or a .366 batting average. So this is talking about every single at-bat of Ty Cobb. So this is actually going to be a parameter. And so to explain that a little bit more thoroughly, the population in this instance is going to be all of Ty Cobb's at-bats. So a sample might have been if he had gone through and we looked at his at-bats in his last 3 years or something like that. But the population is going to be all of Ty Cobb's at-bats, and this is describing all of them. Okay, so and I do realize that one's a little bit tricky, and there's a way to argue it for a statistic. Don't worry, that one will not be on a test. All right, so for C, alcohol use, in a national survey on substance abuse, 66.4% of respondents who were full-time college students, aged 18 to 22, reported using alcohol within the past month. So the 66.4% is only in reference to the respondents of the survey. So this is only about the subset or the sample. So this is going to be a statistic. And for D, following the 2006 national midterm election, 18% of the governors of the 50 United States were female. Well, the population here is the governors of the United States. So they are looking at the entire population, so all 50 of the governors, and so 18% of the entire population were female. So this one is going to be a parameter. All right, let's talk about the process of statistics. So first, let's talk about descriptive statistics. So that descriptive statistics consist of organizing and summarizing data. Descriptive statistics describe data using numerical summaries, tables, and the graphs, which we already talked about. Now, inferential statistics uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. So inferential statistics are where you're going to infer something about the entire population. So the process that we go through, so identify the research objective. So essentially, you're going to figure out what questions need to be answered, or questions need to be answered. You're going to collect the data. I do want to make a note here that how you collect the data is really important. So if it's not collected in a valid way, then any information that you draw, any conclusions you draw aren't going to be valid. Remember this idea whenever we talk about convenience sampling in a couple sections. Okay, and then we're going to describe the data. So we're going to give an overview so to give some insight into the type of statistical methods that were used, and we discuss that in detail in later chapters. And then we're going to perform inference. So we're going to apply the appropriate techniques to extend the result obtained from a sample to the population. So we'll be able to say, based on what we found, we are 90% confident that this will also apply to the population, things like that. And again, we'll talk about that more in later chapters. So first, let's talk about this quick example. So we're going to go through, we're going to identify the research objective, the population, the sample, the descriptive statistics, and what can be inferred. So Gallup News Service conducted a survey of 1,019 American adults aged 18 years or older in August 13th through 16th of 2007. The respondents were asked, generally speaking, at what hour of the day or night are you personally at your best? Of the 1,019 adults surveyed, 55% said that they were personally at their best in the morning, so between 5 a.m. and noon. Gallup reported that 55% of all Americans felt that they were personally at their best in the morning with a 3% margin of error with 95% confidence. So the research objective is the question that they were asking right here. At what hour of the day or night are you personally at your best? So for the research objective, so what time of day are American adults at their best? So trying to find that out. And then for B, the population, so it's going through and it's telling us that it conducted the survey on 1,019, but it's the American adults aged 18 years or older. So that's going to be who we're interested in. So the American adults that are 18 years or older. And then the sample is going to be the 1,019 American adults that they surveyed. And here we got the 55% here of the ones surveyed. So the statistic is referring to the sample. So this 55% of the sample were personally at their best. So in the morning, so the 55% of respondents were at their best in the morning. And then what can be inferred is that 55% of all Americans are going to feel at their best in the morning. So 55% of all American adults are at their best in the morning. All right, let's talk about types of variables. So we're going to have qualitative or categorical variables that allow for classification of individuals based on some attribute or characteristic. So often this might be like the color of somebody's hair, the type of car they drive, things like that. Quantitative variables are going to provide numerical measure of an individual, and arithmetic operations such as addition and subtraction can be performed on the values of a quantitative variable and will provide meaningful results. So with quantitative variables, the big key here is that if you perform some sort of arithmetic, so if you add it to something else, or if you take the average, or if you subtract, or if you perform some sort of mathematical operation on these quantitative variables, your result is going to make sense in some sort of way. So let's look here and decide if these are qualitative or quantitative. So the number of siblings, well, if we were to go through and survey an entire room of people on how many siblings they have, we could determine that the average number of siblings per person in that room is whatever, maybe 2.5. That would make sense. So it would make sense for us to take the average of that, or if we had a group of people, we could add all the siblings together and say that within that group there are 12 siblings, things like that, and it would make sense. So that's going to be quantitative. Okay, the grams of carbohydrates in a donut. Again, if we take the grams of carbohydrates in a donut and we were looking at how many grams of carbs are in an entire box of donuts, adding those together is going to make sense. So this is going to be quantitative. The number on a football player's jersey. Now this is still a number, but if we were to take 2 or 3 football players and add their numbers, does the result make any sense? Well, no, it has no relevance to anything. So the number on a football player's jersey is actually going to be qualitative. And again, that's because you cannot perform any operations, any mathematical operations on those numbers, and it have a meaningful result. So the assessed value of a house. So we have the value of a house, and we wanted to see how that compared with other houses, or perhaps find the average assessed value of a house in a neighborhood. We could take assessed values of multiple houses and average them, and that is going to be a worthwhile result. So that is also going to be quantitative because we can perform an operation on it. A phone number. So your phone, if you have a phone number of 2 people and you were to add them together, you're not going to get a meaningful number. So this is really just descriptive in terms of a classification. So around Atlanta, we might have people's phone numbers because we're interested in their area codes. So the phone number is going to also be qualitative. Student ID numbers. Again, if we have student ID numbers and we add them together, we're not going to come up with a meaningful result. It's not going to give us any more information about the students whose IDs we added or averaged or subtracted. So this is also qualitative. So let's talk a little bit more about quantitative variables. Quantitative variables, so those are the ones with numbers that can have an operation performed on them, so where we can add, subtract, average, things like that, and get a meaningful result or have it make sense. So quantitative variables can be split into discrete variables and continuous variables. So a discrete variable is a quantitative variable that is either has a finite number of possible values or a countable number of possible values. The term countable means that the value results from counting, such as 0, 1, 2, 3, and so on. To be really clear, though, that doesn't mean that it always has to be whole numbers that you're counting by. So, for instance, we might be counting quarters. If we were counting quarters in terms of dollars, we'd be counting 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, 2, so on and so forth. But that's still going to be discrete because if you're counting the value of quarters, at no point are you going to end up with 0.17 or 0.175, so on and so forth. For a continuous variable, so this is going to be a quantitative variable that has an infinite number of possible values that are not countable. So with discrete, we can typically count, and with continuous, these are usually things that are measured. So if we want to talk about the weight of a dog, if we want to be really, really precise, it's not going to be something to the 10th of a pound. So maybe we want to measure to the ounce, or maybe to the gram, or milligram. So we could continue on and on and on and become more and more definitive. So it's not something that's countable. It was something that would be measured. So for continuous, you're thinking about things that are measured. And for discrete, we're thinking about things that are counted. So for A, the volume of water lost each day through a leaky faucet. Well, the only way to figure out that volume is to measure it. So since it has to be measured, it's going to be continuous. The length of a country song, again, this one's a little bit tricky because we normally think just to the second, but it could actually be a fraction of a second. So the length of a country song would be measured, which is also going to make this one continuous. At rest, pulse rate of a 20-year-old college student, well, whenever you're taking a pulse, you count. So this is going to be discrete. So you wouldn't say that somebody has 52.6 for their resting pulse rate. You would say that they have 52 or 53. The number of sequoia trees in a randomly selected acre of Yosemite National Park. Again, we're going to go through and count those trees. So since we're counting that, it's going to be discrete. The weight of a randomly selected hog, well, I accidentally gave this one away, but you're going to be measuring the weight of the hog. So this is going to be continuous. The temperature on a randomly selected day in Memphis, Tennessee. Well, you don't count the temperature, you measure the temperature. So this also is going to be continuous.